Hello, this is Keith Owen. Welcome back. Have you ever wondered which age group is secretly driving your revenue? Is it the 20-somethings splurging on an impulse buy, or the 40-somethings quietly stacking up totals? Well, in this tutorial, I'll show you how to slice your data into a clean, intuitive age bins like age 20 through 29 or 30 through 39, etc., and use Python-powered pivot tables inside of Excel to reveal the revenue story hiding in plain sight. So if you've ever wanted to turn raw numbers into razor sharp insights, this is your time. So let's get into this. So here's a small little data set that has revenue and expenses, the country, the dates and years, and of course what we're going to be focusing on are revenue per age groups. So we got our age listed here in our columns, and over here to the right is just a snippet of what we're going to be building together, not only using a Python pivot table, but we're also going to create this within Excel pivot tables also. So what our end result is, what we want to determine is how much revenue is being generated through each age group that we have here. Now my data set, the minimum age is like 25 and the maximum age is 59. So that's why we have these individual age groups here. So let's first see how we could do this in Python within Excel. And again, you could follow this along in standalone Python in whatever IDE that you use. So let's first create the data frame. So basically what we want to do is we want to enter in Python mode equal py, tab into that, and then we want to create a data frame, which is basically selecting the data in our Excel table and putting that into a Python pivot table. So I'm going to call my data frame df is equal to, and all you have to do is just select your data, Control A, go ahead and select this, Control Shift down arrow, and then Control Enter to add in the data frame. So there we have it. We have a data frame. And just so you know that Python and Excel comes with two different standard calculation speeds. And right now I'm on the free version of it. So whenever I do a calculation, you'll see a little regeneration icon here that it's just trying to build out the formula and stuff like that. So if you look up on here, is I'm using the standard Python and Excel calculation speed, and if you click on learn more, basically it's going to tell you that you can have more calculation speed if you go ahead and pay for it. So after we create the data frame, we're going to go through this step by step. Now, going forward, yes, I could do all this code in one cell block, but I'm individually entering this stuff and displaying it out so you can visually see what is going on behind the scenes of all this code. So basically what I want to do is I want to be able to dynamically look at our data frame and get the minimum and maximum age in our data frame. So what we could do is enter in Python mode again, equal py, and to get the minimum age is, I'm just going to give it a variable name. A minimum age is equal to our data frame, and then we're going to access using square brackets the age column. So remember, this is case sensitive, so this has to equal exactly what's in your data frame. Okay, and then we're going to use the min function. Control Enter to commit that, and you could see our minimum age is 25. Now we're going to do the same thing using the max function, equal py, tab into that, and we're going to call it max age is equal to our data frame column age dot max. Control enter to commit to changes, and as you can see, our minimum and maximum age is there. Now what we want to do is define our bin width. Basically, what is our bin width? And you could see we could set it to 10. Okay, now let's go back over here. Now bins are just like groups in Excel. We're going to group the data. So our bin width is basically 20 to 29. So that's actually 10 numbers there. That's what we refer to as the bin width. You could set it at anything else. If you wanted to create a smaller bin or group size like 20 to 25, then your bin width would be 5. So let's go back here. Is we're going to set our bin width equal py, give it a variable name of bin underscore width, width is going to be 10. Control enter to commit that. Okay. Now what we want to do is we want to create a dynamic bins. So in other words, we need a starting point, and we ensure that bins start at round numbers. So let's first get the starting number, dynamic bins starting number, which is our start here, equal py start is our variable name, is equal to, we're going to have a minimum age, which is what we calculated above, min age, and then we're going to divide that by our bin width. It's already there. And then after that, we're going to multiply that by our bin width, width. Let's control enter that. Okay, it's 20. Now, how did we arrive at 20? Okay, in this particular case, our minimum age is 25. It goes there. And when we divide that by our bin width of 10, as you can see over here, 25 divided by 10 is actually 2.5. But since we have a double slash here, what that means is we're going to round down to the nearest whole number, which is 2 in this case. We multiply that by our bin width, which is 10, and that equals 20. So, okay, and now we're going to do the same thing, but we're going to create our maximum or our n bin number here. Okay, so that's going to be, let's go ahead and let's copy this. Control C, escape. Let's go over here, equal py, tab into that, paste that in there. But now we're going to use the maximum age. Then control enter. And give it a second here. Now what we want to do is we want to modify this slightly. Okay, and I'll explain why this is going to work this way. So I'm going to go ahead and do that. And then bin width is going to be +1. Make sure we got that. And then we times it by the bin width. Control enter. Now we get 60. Now let's look at this dynamic. So our maximum age is 59. We're going to divide that by our bin width, which is 10. That's going to equal 5.9. So again, what this 2 slashes does, when it makes the division, we're going to round down to the nearest whole number, which is going to be 5, okay? We want to add 1 to that, which is going to be 6, and then 6 times the bin width of 10 equals 60. So in other words, again, our maximum age is 59, so we want to be able to get up to the nearest number above that. So that's why we got 60. Now we're going to list out our bins. Okay, and you'll see how this works in a second. So again, equal py, tab into that, name the variable bins equal, and then we're going to create a list, and then our range is going to be str start, which is what we just calculated above, comma, end plus 1, comma, bin width, control enter. Give it a second to calculate. Okay, let's see, I might have mistyped something here. Okay, let's see what's going on over here. Error, name end is not defined. Okay, what did oh, here, this is what I did. When I copy and pasted, I didn't change the variable name. So control enter. Okay, it creates a list for it. So let's bring that out as an Excel value. And let's close out of this Python editor. And as you can see, we created a list of bins. So in other words, what this does, it creates a sequence of numbers starting at 20. Okay, our start number is 20. And ending at or before 60 plus 1. And then stepping by 10. In other words, 20, 30, 40, we're stepping up by 10. Now, the upper limit means that it's non-inclusive. So in other words, if I didn't add 1 here, that means it would end before 60, and it would only stop at 50. We didn't want to do that. So we add 1 to make sure, and then it itself is included if it's multiples of the bin width. Okay, the bin width is the spacing between each edge is what they call it. So the spacing between, so 20, 30, 40, the spacing between each edge. The edge is like 20, the edge here is 30. So that's what they refer to. And when we create the list, after we calculate all that, it forces it into a full list of integers. So that's why we got bins values of 20, 30, 40, 50, and 60. Okay, now we want to create labels. What are the labels in this case? So the labels are what you see here, 20 through 29, 30-39. So those are the labels. So we want to go ahead and create those labels here. And let's go ahead and do this, and then we'll walk through basically how this is done. So equal py, tab into that, labels is going to equal to, so what I'm creating an empty list right now, and then I'm going to use a for loop. Let's see, I in range length of bins minus 1. You have to put the semicolon, tab into that. That's important. Lower bound is going to equal to bins, and we'll walk through this together. Once I get all the code written, enter, upper bound is going to equal to bins I plus 1. Let's see, close out of that and then subtract 1. And then enter. Then our label that we're going to create is going to equal to an F string, quotes. Let's see, LO. It's going to evaluate at runtime what the value of lower bound is, minus, and then the upper bound. And you're going to append that as it goes through the labels. As it goes through this for loop, we're going to append it to the labels list that we just created up above. Append. Then tab back. And then I'm going to display the values of the labels list. So Control Enter. Give it a second. I might have did a typo again. Give it a second. Okay, Glenda is not defined. Okay, let's see. Right here. Okay, what else? Let's see. Labels, append. Okay, let's scroll down here. Got to use labels dot append. Control Enter. Okay, it created a list for us, and now let's extract the value into the Excel cells. A shortcut key, Control Shift Alt M. Okay, so we created our labels, as you can see here. Now let's step through this code above here. So what this means is for I, okay, it's going to start, I is going to be equal to 0 in the beginning. It's 0 index in this range. So basically what is our bins above here, our bins, the values of this, the bins are, we have a list ranging from 20 to 60. So there's 1, 2, 3, 4, 5. Okay. So our bins is going to be 5 minus 1, which is 4. Our length is, so our length of the bins is actually 5 numbers or 5 list elements, okay, minus 1, which is 4. So it's going to cycle through this 4 times. Now the lower bound here is, and I'll show you just an example through the first iteration of it. So I'm going to do equal py, and then lower bound is going to equal to our bins, the first index, because it's 0 based index, and then Control Enter. So we first start out with 20 as the first iteration. Now our upper bound in this case is going to be equal to py upper bound is going to equal to bins, and it's going to be 0 plus 1. And then minus 1. And I'll explain this in a section. So Control Enter. Okay, so in other words, when it's going through this for loop, we want to create our labels for the bins. So we define our age groups. So we want to go from 20 to 29. So if our lower bound is equal to 20, our upper bound is going to be, because we're on the first iteration of it, so our bins is going to be 0. So it's going to access 20, okay, because that's the first iteration. We're going to add 1 to that, meaning it's not 20 plus 1 equal 21. It means that it's going to take 20, okay, over here, and then let's access the next element in the list, which is 30. So that means that this value here at this time in the first iteration of it is going to be equal to 30. We're going to subtract 1, which is 29. Okay, so now when we do that, let's scroll down here. So we got that. Now we're going to label it. So our upper bound is 20. Well, our lower bound is 20. Our upper bound in this case is 29. And we're going to format this string so it's going to evaluate lower bound here, 20-29. And then we're going to append that value here to the labels list that we were creating above here. So once it goes through all those iterations, it comes out with these values that you see here. Let's escape out of there. So now let's look at the label itself in this particular case. So let's evaluate that. Okay, so you can see through our first iteration, we're going to get the label as 20 through 29, and it continues on that through the iteration. So now let's from this point, we want to create a new column in our data frame called age group. The reason why we want to do that is because when we get to the pivot table portion of it, we want to be able to group by our age group column, and then we're going to sum up the revenue for all the values that pertain to that particular age group. So we do that by, let's go through equal py, tab into that. We're going to take our data frame, and we're going to create a new column called age group. That's going to equal to this function, and we're going to step through how this works. So we're going to do a pandas function, cut, it's called cut, and then tab into this, or not tab into it, use a parens, data label, our data frame age column, comma, and it takes these parameters called bins is equal to bins, comma, labels is going to equal to our labels variable that we created above here, and right equal false, false. Then press enter, and I'm going to do dataframe.head, which is once it creates this new column we just typed up above here, we want to spill out the first 5 rows in our data frame. Control enter. Okay, probably another typo. Give me a second here. Okay, syntax error. So let's see what I did above here. So what I did above here was just basically I left out this right paren up here. So that's why we got that error. So it creates a data frame. Let's spill the results. Another way to spill the results, right click on here, Python output Excel value. Okay, so grabbed our data frame, grabbed the first rows in our data frame, and it created an age group column. So let's step through what this pd.cut does. So let's go how binning works. So let's go over here, and I explain this, okay? So our bins in our particular case are 20, 30, 40, 50, and 60. And our labels associated with that are what you see here. So basically, this defines 4 intervals. Remember, in our previous code, it said for loop, and it did a range of our bins, and we calculated it be 4 intervals. So in other words, when you see this is an interval, which is 20 and 30 is one interval. Then it goes from 30 to 40, which is the second interval. 40 to 50 is the third interval, and the last interval is 50 to 60. So let's scroll down here. And so each interval includes the left edge. The left edge, what we're talking about here, the left edge of this one bin, 20 and 30, is actually 20. So we want to include that. So whenever the age column value is equal to our within the 20s, we want to include it within that one interval. So let's scroll down here. But excludes the right edge. Okay, the right edge means that our first interval is 20 to 30. So basically, if our age happens to be 29, it falls within this label here. If it is equal to 30, we want to exclude that right edge, which is 30, and put it into the next bin or label, which is 30 to 39. So when we go back here and we have this parameter called right equals false, let's go back here and let's step through what that means here. When right equals false. So by default, pd.cut uses right inclusive intervals, meaning that 30 is included, but 20 is not. So what we wanted to do is by setting right equals false, it flips that logic, and it says intervals become left inclusive, meaning that age 20 falls into the first bin and age 30 moves to the next bin. Okay, now this is useful when you want to treat the lower bound as inclusive, like age ranges that start at 20 and go up to, but not including 30. So that's what that means. Now let's scroll down here. It says, now how it evaluates each value. So for each value in the data frame age column, it checks which bin the value falls into based upon the values in our bins and right equals false. And then it assigns the corresponding label from the list, the labels list that we created. And let's scroll over here just a bit. Okay. So let's use an analogy here so you have a clearer picture of what bins are in Python. So imagine you're at a nightclub with 4 age group based lounges. You have Lounge A, only has ages 20 to 29, and as you can see, it goes up through ages 50 to 59. In our case, because our maximum age in our data frame is 59. So when the guest arrives at the door with their birth dates, meaning what their age value is, and the bouncer is in this particular case is referred to pd.cut. It checks each one and says the following. So if you're 34, head to Lounge B, because Lounge B, as you can see, is for ages 30 to 39. Okay, and that's the 30 to 39 crowd. Now the bouncer, which is pd.cut, uses a guest list of age ranges. Age ranges, again, falls in our bins list that we created, and name tags for each lounge, which is our labels, the values in our labels list. Now, if someone's age doesn't fit into any lounge, in this case 19 or 60, they get no label or tag, and we just label it as not a number value. But in our case, we avoided that because we created a min and a max value, so we're not going to create any bins outside that range. And then again, you tell the bouncer right equals false, which means that we include the lower range of the bin, but not the upper. So 30 is welcome in Lounge B, but 40 moves on to Lounge C. So hopefully that makes a little bit more sense of what bins are for. So in other words, guess equal the values in the column, the age column in our data frame, and lounges is just referred to as our bins, okay, and our name tags are referred to as labels. And the bouncer logic is conducted through the pd.cut method. And then the right parameter, false, meaning the lower bound is inclusive. It includes that. And the upper bound of it is exclusive, meaning 30 doesn't fall into 20 to 29 group. It falls into the 30 to 39 group. So that's how that is. So let's go back here. Now we got that. Now let's create the actual pivot table in Python. So we do that by equal to, we create, py first, and then pivot. I'm just giving it a variable name called pivot. We take our data frame dot pivot underscore table, and then our index, which is our actual row values, is equal to our age group column we just created, comma, our values is basically, and you'll see how this looks, is equal to the revenue column. Okay, and then what do we want to do with the revenue column? Well, we want to sum the revenue for each age group. So we do an ag function, and we're going to assign it to sum because we want to sum the values. And then enter, and then we want to reset the index, pivot underscore, or no, dot reset underscore index, control enter. Control Shift Alt M to spell the values. And as you can see, what it did was, now let's go up to this code up here, look up at the formula bar. When I say reset index, by default right here, the index column age group is going to be the index, and our revenue column is going to be revenues. So in other words, this would be the index and this would be the column or whatnot. But basically what we want to do is in a data frame, we want to move the age group away from the index and create a separate column for it called age group. So this is what we did here. We summed up all the values for all the ages that fall within this group here or bin, and we got the individual values. Now let's see how we can do the same thing. It's much quicker, of course, but let's see how we can do this with the pivot table within Excel. And then we're going to compare the two, and you'll see that they equal the same thing. So let's go over here. Let's go over, select anywhere in your data range here, and we want to insert a pivot table. Go up to Insert Pivot Table, and it automatically detects where all the data is. And then let's see. And then we want to create it on an existing worksheet, and we want to go over here, click OK. Okay, so what we want to do is we want to duplicate that pivot table we did in Python. So we want to use the age column and put that into the rows. And you'll see how we group this in a second. And then we want to sum up the revenue. Okay, which it's already there. Okay, let's get rid of sum the revenue, sum the age. Let's get this out of here. Okay, so basically we did the pivot table within Python. The index parameter refers to the rows area, and the values parameter within Python pivot table is referred to the revenue column, which we stated, and it falls into the revenues area over here. So now how do we get this into age group? So if you click on this, right click, and you do group, and then what it does is it grabs the minimum value in our age column, okay, which was 25, ends at 59, okay, which is the max value was 59. But what we want to do is we want to start it at 20, because what this will do is starts at 25, increases it by 10, and gives us a range of 35, and we don't want to do that. We want to do 20 here, tab into that, and then click OK. And then as you can see, it created our labels for us. It grouped each one by 10. And if we go ahead and copy this, Control C, let's go back over here. Control Alt V, and we just want to, in this case, paste the values, press enter. And as you can see, the numbers match up exactly, match up perfectly. So I know this tutorial was long, but hopefully it gave you an idea how you can create age groups within Python, and age groups are referred to as bins, and then compare that to how you can do the exact same thing in Excel pivot tables. So again, I want to thank you very much for staying by here. You could see there will be a link in the description of this file that you could download and follow along. So again, thank you for stopping by. You have a great day. And remember to subscribe to my channel. And as always, please like and share this video. Thank you, and I'll talk to you soon.